Hello there and welcome again to my workshop. Today we are going to be setting up all the parameters in NC Studio to a CNC Router. So it's a fresh new program loaded in, and so we're going to start from scratch, and I'll show you everything you need to do to get NC Studio working correctly with your CNC router or mill. Okay, so this is NC Studio, and I'm going to show you now how to set the parameters in this program for a CNC router, and this will work for any CNC router or milling machine for that matter. The controls are very similar to Mark III, except it's just laid out a lot differently. Now, what we need to do is to set up the steps per then as you would in Mark III. In other words, to get the stepper motors and screws to operate very accurately. Now what you need to do is, well, I'll just open some of these windows. That's the log window, management window, edit window if you want to edit some script as in G-code. This is the I/O window. We'll be coming to this very shortly, because this is where you check to see whether your limit switches and that are working. But the one we need to work with primarily is parameters. Now, there are some things in here, but if I was you at the very beginning, is leave them alone. Don't alter anything at all. Now then, what we want is manufacturing. So we go into that, and the code word to put in here, or the keyword, is just simply lowercase NC Studio. And press OK. So now we come into the parameters section. Now this is to set up the travel of each axis, but first of all we need to set the X, Y and Z motor parameters. Now it's a fairly easy process to do this. Might be a little long-winded, but it's fairly easy. It just means altering these numbers to suit, or to get an accurate reading on each axis. Now I'm going to come over here and I'm going to alter the jog setting to 10 millimeters per pulse. So that means every time you press one of these, each axis is going to move 10 millimeters. So we have a measurement, so we can measure to see how accurately it is actually running. So I'm going to bring the camera down to the Z axis, and we'll take it from there. Okay, so this is the Z axis, and I'm just going to scribe a line on here if I can get it accurately. Now you might see that a little different because you're looking down at an angle at it, but that is exactly in line with the top of this, parallel. Alright, so we're going to use that as our measuring mark to the top of this bearing here. So what I'm going to do is I am going to send the Z-axis down what should be exactly 10 millimeters. like so. Okay, now we'll get within a few thousandths of an inch this way, but really we need to get a DTI gauge on it later. I'm trying to keep my big head out the way so you can see. If I hold that parallel there, so I'm trying to do this and keep my head out the way. Oh, come here. Okay. That looks to me like pretty well around about 7 millimeters. So we know it's quite a way off. So I'm going to take it back up, and it should go up exactly the same amount. So now we're going to alter some of the steps per in the Z-axis in the program. Okay, so this is a fairly simple process. Now, because we were getting less of a travel than what we should have got, and we are going to only alter the Z-axis for now, I would say that this number needs to go, well, I think we need to go down. So I'm going to put 0, 0 there, just to see which direction we need to go. And I'm going to say apply, and then we're going to do the same measurement again and see what difference it's made. Okay, that's much better. Okay, we're heading in the right direction. We have got 9 millimeters there, so yeah, we're heading in the right direction. So I'm just going to take it down, I'm going to drop that figure down a few more points, and we'll see where we go with it. Oh, that is pretty good. That's not far off. I think just a little tiny bit more. I've set that at let me see, 0.00225. I'm going to take the 220, and I think that's going to be the number. Okay, here we go. Right. So we've got a winter storm blowing outside. Okay. Let's have a look here. Hope my head's not in the way. That's not far off. That's not far off. Okay, so I'm just gonna fetch it up, and what I'm gonna do is take it down 50 millimeter, because the longer the distance you take it, the more of the inaccuracy will appear, if there is one. Okay, now I've done it about half a dozen times now, and I've actually remarked the line up here, so it's about a millimeter further up. So now we're going to do 5 pulses, which is exactly 50 millimeters. And I think you're going to see that that's pretty well good. So sure you can tell there, that's within a few you know, a few tenths, or actually a few hundredths of a millimeter. I will get a DTI gauge on it. So I'll show you what figure I came up with. Okay, so I'll just zoom into that figure there, and you can see that it's 0.00250. Now that's pretty accurate. It's going to be a couple of digits either way or either side of that for the exact amount, but by eye with a ruler, fairly accurately, it appears to be close to that figure. So I'm just going to alter the other two axes because they should be identical, as they're identical motors and identical screws. So here we go. 250 and 250, and something you might not have seen, I'll just pull back a little so you can see this. I'll do it in real time, is press the apply button, which is down here. So now all three axes should be close. Now these are the feed rates, which we will come to at a later date, which is start off, feed rate is 300 millimeters per minute, okay, and the maximum feed rate of Z is 1500 millimeters per minute. Now we're going to see how we go with those. This is for the Z axis. Set the angle per post for the Y revolve. This is for a fourth axis. And of course, with NC Studio, you slave the Y axis to the fourth axis. This doesn't apply to us because NC Studio does not run the spindle. However, I will alter it to what this spindle is, because one day we might be able to work out what, how to do it with NC Studio. But at the moment it will only run a VFD. So we will apply that. Now what we're going to do is give some parameters of total travel, but to do that we need to home everything, in other words get it to find the home switches, and B, measure it sort of mechanically to see, well, how much travel we got. I think it's about 360 millimeters in the X and Y, but we'll measure it and we'll find out what it is. So at the moment we can't fill this in, so what we're going to go to is the I/O. I hope you're picking that up. So this is the I/O state window. So what I'm going to do is activate each limit switch just to make sure it's working here. Z, X and Y are all working. Okay, so the next thing I'm going to do is make it home itself, and what you'll see is, now this is the machine coordinates here, this group of numbers here, and when it homes this will turn to 0, and a little 0 tag sign will come up in front of each of the X, Y and 0 coordinate numbers here. Okay, so here's the Z. It moves at quite a sedately level, which is quite nice when you're homing. Okay, I'll just zoom in so you can see what's happened there. And you can see there's that target I was talking about, and the machine coordinates have zeroed. The numbers next to it is the work coordinate, or set in the G54. So this time I'll leave it up there so you can see the numbers coming down for the X. Okay, so now what we're going to do is measure each axis and set the measurements into the maximum travel of each axis in the program. So the Z is 120 millimeters. Okay, so it's into parameters. And the Z, now the Z is always measured in the minus direction. So this is altered to minus 120. So the next one we'll do is the X. Okay, that's 380. Look, it would do 390, but I'm going to say 385, just to be on the safe side. So this is 385, and the Y I'm going to set at 380. And now we're going to press apply. So that basically is how to set up NC Studio. It's similar to Mach 3, but laid out in a different way. A couple of things I'll show you. Now, obviously this is working off the keyboard or off the screen. You know, you can use these to operate. Of course, these numbers here, I'll zoom into the screen so you can see a little bit better what I'm doing here. Okay, just a few things I'm going to show you here on the screen. If I can talk over the storm that's happening outside. Now this area here, this is the work coordinate, and we'll be setting the work coordinate in a minute. This slider bar here is the feed rate in percentage terms of whatever you set it to in your CAD program. Let me see. Okay, spindle RPM, very simple. It's 24,000 RPM. And you can, in here, you can set the RPM at a level you want. You turn the spindle on here and off. I don't have a spindle controlled by this program at the moment. And of course you have X, Y and Z. Okay. At the moment that's full jog. I'll show you something else about that in a minute. And this here, if you set, like, it's the same as like Mach 3, I suppose. If you want to move 10 millimeters in any one direction. Now you saw this in operation when I was setting the steps per, but it will go down to 0.01 of a millimeter, which is well, you can hardly see it. It's about, not far off a thousandth of an inch. Yeah, there's that. So you've got 0.01, 0.5, 0.1, 0.5, 1 millimeter, 5 millimeter, and 10 millimeter, which is very handy to have actually. And I'll take you down to the machine now, because I'll just show you what's about two different jog speeds. Okay, so two different jog speeds. If you just press the keys up here, or the same as Mach 3, so it's slightly different actually. It's 6, 4, 1 for down in Z, 9 for up, and of course it's 8 for back, 2 for forward. So it's only the Z that's different from Mach 3. But there's two different speeds. There's the ordinary speed, which is that. Then if you press the control button, not the shift button, shift is Mach 3, control is NC Studio, and that gives you rapid feed. Like that. Okay, so we're going to set an imaginary work offset now. And before I go any further, one very important step that you must do for everything to take effect, and that is to shut NC Studio down and restart it again. Now to zoom in and out of here, you just left click, and now you can see that is now the full parameters of our new machine. The little X you see in the middle here, that is the position of the tool at this moment. And yeah, all pretty good. So what I'm going to do, you'll notice up here, you may be able to pick it up with the camera, but those targets are gone. So we're going to rehome all the axes like this. Okay, so we'll close that. So now we're all homed. The program and the machine, the computer, they all know what everything, what they're all doing and where they are and what the parameters are. So what I'm going to do now is just set up an imaginary G54 or work offset. just something about the jog rate. The jog rate, okay, that's normal jog rate, but if you press the control button, now in Mach 3, it's a shift button. NC Studio is control. Okay, so we're just going to fetch it over here a bit, and then back a little, and then down, and we'll just set an imaginary G54 or work offset there, and really you just go hover over each individual box here. This is the X, press for 0, Y, press for 0, and Z, and that is now the work offset set. Now I just want to see whether the soft limits are working. So we're just going to get the X, and I'm just going to drive it all the way over here and see if the program picks it up and stops it. Yep, there you go. So because this is yellow and not red, you can take it back. If that turns red, it actually locks you out. So what you have to do is turn the power to the stepper motors off and manually wind the screw to take it off the that particular area, and everything's fine again. But that's one peculiarity with it. Okay. So we'll just lift this up a bit, bring this forward a bit. Okay, so that is exactly how to set up NC Studio to a CNC router. Set the parameters. It can be a little long-winded, but if you're patient with it, it's fairly easy. I will, however, put a DTI gauge on it, like I said, and you know it's going to be a couple of digits either way to get it absolutely perfect. And you know it'll run that CNC router without a hitch. And I have actually used in the past NC Studio for a couple of years, and I know it's not a bad program, fairly easy to use. So I hope that gives you a bit of a start with it. And the next time we come back looking at NC Studio, we will do some cutting with it. You know, this video will just go on too long otherwise. So I've given you enough information to set your machine up if it isn't already set up when you get it, and a little bit of an insight how to operate NC Studio. So please like and subscribe, and if you really like what I'm doing, you could consider becoming a patron to the channel. Patron information is down below this video in the video description area, where you'll also find a discount code there for Carveco, any of the Carveco products, and you will also find a discount code there for Fusion 360. It was a nice healthy 20% off, and that is off the the professional version, whether you buy it or lease it or whatever it is. But those discounts are only available at the address that accompanies the code. So thank you for joining me, and please pop in and have a look at one of my other videos. So bye for now.